REI? Yeah, I have another one that doesn't work for this kind of thing, but it's a Gorilla tripod, and you can actually bend it. And like when I go hiking or something, we could put it up on a tree and just curl it around the tree limb, and then it can record something. It's really cool, but this works for now. Okay. Section 1.1. If you don't have your book, I'm just going to describe it to you. Section 1.1 really is just ways to succeed in mathematics. Right? So obviously, number 1 is show up to class. Number 2 is take good notes. And one thing that I like about the fact that I'm videotaping this is you might feel a little less required to write every word I say. I always have students that are like just furiously, I don't even know what the hell I'm writing. I'm just, it's crazy. You're not going to learn that way. You want to wrap your brain around something in class, not go, I'll look at this later and figure out what I wrote. No, that's no good. You're not going to do that. It's going to look freaky. So I'm hoping the fact that I'm videotaping, it's funny that word's still around, I'm recording this, it'll make you feel less needful to write everything I say. Especially because my grammar sometimes sucks. You don't want to write that down. Blah, blah, blah. And another big thing is what I do for myself, and what I did for myself when I was in school is I made this little like Word or Excel thing where I would block out my classes, I block out when I'm working, I block out when I had to be helping my mom out with something way back when, or when I had to do whatever, and then I look for my white space, like, oh, I can sleep here, oh, I can eat lunch, that's nice. Or I can do homework here. And then I wrote, do math homework or something. Because we're human. If we write it down on a schedule, we're that much more likely to actually do it. Right? Okay. Just a suggestion. So 1, 2, they get into the actual stuff here. So the very first thing we kind of go over is just the real basics about how do we, write numbers? Not even just, I know we all know how to make a 6. But if I wrote up here that number, what is that number in words? Good. I like it. So it's 6,987,147, right? And we'll be a little more careful when we get to decimals. Let me just show you an example of a decimal right now. The way you say this is 1 and whatever that is. It's actually, anybody know what that is? 1 and 98 hundredths. I love it. So we're going to get into decimals later. But that word "and" in English has a very specific meaning in math. It means where the decimal goes. And if you've ever written a check, you know this all too well. You're actually very careful about where you write that "and." It's just because it means the decimal point. It's exactly why we're careful when we write checks. If you've never written a check, congratulations. What to tell you? That's all right. That's good. You do everything online. I don't know. So the very first part of it is there's going to be problems that just say both directions. They're going to give you like this. Write it in words. They're going to give you in words. You got to write it in numbers. Cool. And of course, inherent in that is knowing what the places are. So decimals, of course, kind of suck. They're places. We got to remember what those are. But just knowing, for example, that this is millions. And if I backed up a little bit, that's now in what place? Billions. So thousands, millions, billions. Next would be trillions. Somewhere out there, there's actually sextillions and all this stuff. Sounds like something that Austin Powers made up. Okay, so we're not going to go too much far past billions, those class, but there are things for that. There's always the fact that other countries don't use commas and decimals the way that we do. So I don't know if you come from a country where this actually means 4.981. You got to help me out a little bit. You have to. It's part of that whole translating from one language to another. So we would say here 0.91 like that. There's a lot of other countries that would actually use the comma where we use the decimal and vice versa. So if you're in that situation, you have to kind of work on that with me. I'll try to give you a little bit of leeway with that. Okay, cool. Blah, blah, blah. Oh, at the bottom of page 8, they give you the places that we just went over. Okay. Then we get into this kind of thing. This is section 1.3. I warned you I was going to go a little quicker. And these sections are kind of broken out really well, and they each have one kind of basic idea in them. Yes, sir.
So, I like, okay, that's 69871.7. So I thought I know this doesn't make no sense. And I think the highest number, the second highest number would be 700, because they go up because they put like a 0. Every time you go to like a 5. They put like down to make 600, and then they head up to make it.
So you're saying about making that into a 7, or are you thinking about like rounding?
Yeah, rounding.
So rounding is in our future. We're not there for rounding yet, but we will talk about rounding. Here, I don't want to round that number. I want to know exactly what it is. But if somebody tells me I'm going to make this much money, I'm going to tell my friends I'm going to make $7 million. I'm not going to say I'm going to make $6 million. No, I was going to say I'm going to make $7 million. It's close enough, right? Plenty close enough. I can ignore this because I'm talking about freaking millions. So I'm with you. Rounding makes sense in a lot of situations. Here I'm not talking about rounding it, because if you round it, it's going to make this really easy. You just say 7 million, I'm done. What's next? Right? So I want you to actually write 6,987,147. Actually write all those words out. It's not a rounding problem yet. We're not rounding.
I don't understand the 5-10-100 thing.
So if I have, let's really break something down for a second here. Let me try to use all different. Oops. So this is in what place? The ones place. So we got to start somewhere, right? So this is in the ones place. So if I just have the number 2, that means I have 2 ones.
That'd be 20.
No. Careful. It's in the ones place, right? So if I have the number like this, if I have that number, that very first number is not in the tens place. Because what is this? How do you say this number? 27. So this is this would be 20, right? So why is that 20? Because it's in the tens place. And what's 2 tens? 20. This is in the ones place.
7.
So it's just 7 ones. It's just 7, right? Exactly. So now watch. If I did this, I've changed it. I've changed everything, right? What place is the 2 in now? Hundreds. Because you would say that as 270, right? You with me? We would read that as 270, right? So if I write that number down, you know how to read it. 270. And it's because this is in the hundreds place. This is in the tens place. This is the ones place. And notice is each place related to the place before it? How is each place? That's the ones place. That's the tens place. That's the hundreds place. The next one would be the thousands place. How are each of these related? What do I do to 10 to make it 100?
Yes.
Multiply by 10. What do I do at 100 to make it 1,000? Multiply by 10. It's always multiplication by 10. Think about an odometer. Go with me. Think about an odometer starting at 1. Then it's going to roll to 2, 3, 4, 5, 6, 7, 8, 9. The only way it can roll one more time, yeah, I've accumulated. So all along the way here, do I have a full 10 yet? No, I only have 1, 1, 2, 1, 3. Now I've got 9. The next step, I've got a full 10. So that's why this place would now become 1. And how many ones do I have? None yet. And then I start accumulating more ones, and then I accumulate another 10. So now I'll be in the 20s, 30s, 40s, 50s, 60s, 70s, 80s, 90s. And when I get to the 90s, the next rollover, now I've finally gotten enough to have a full 100. Right? So that's why every place is multiplying by 10, because it takes 10 tens to get to 100. It takes 10 hundreds to get to 1,000. Why is there a number system based on 10?
That's how they figure it
That's how we figured it. If we would have, obviously we don't want to lose our thumbs, but if we didn't have any pinkies, thumbs of course is why we evolved. If we had no pinkies, we'd have a number system based on 8. And what the hell would that look like? I don't know. If you take Math 120 with me, you would find out. We actually investigate base 8 and base 12 and all this other stuff. Weird shit. And we talk about Egyptian numbers and Babylonian numbers. And anyway, let's just focus on our numbers right now. Does that make any more sense? So if I had this, nobody else, how would you say that number? How would you?
The 10.
Now, just how would you say that number?
5,082 cents.
No sense. It's not money. I don't know what it is. It could be horses. It could be shoes. You with me? I don't know if it's money or what it is.
5.
I could say it's $5,082. I don't know, right? So 5,082, done, because I don't know what it represents. You with me? So the 5 must be in what place, based on what you just said? Right? You said 5,082, so this must be the thousands place. Right? It's got to be the thousands place. So I always think about like I have a hangman game. Yes, sir.
They even don't even taught this. Didn't taught me this.
Okay. So it's okay. Here's how this works. Ready? Okay. So this is the ones place. So if I have a number there, that means I have that many ones. 1 times 10 is 10. So this is the tens place. So if I put a 2 there, that means I have 2 tens, which is 20, 7 ones, which is 7, 27. That's why when we look at that number, we know it means 27. Because we know every place is based on some multiple of 10. So 10 times 10 is?
20.
Not 10 plus 10, 10 times 10.
20.
That's 10 plus 10.
30.
100. So if I do 10 times 10, right, you can do 0, 0, 0, 0, 1. So it'll be 100. Anytime you multiply by 10, it adds a 0 at the end.
So make it 10,000.
Not 10,000 yet. 10 times 10 would be 100. You actually just add another 0. See that? It's a beautiful thing about multiplying by 10. That's why the rest of the world uses what system of measurement? Metric, because metric's based on 10. The United States, you know what system we use? We use a system based on, for example, how long a king of England's foot was. Do you know that? England doesn't even use that system anymore. Didn't we have a Revolutionary War? Why do we still have... The foot is how long... What did the king... I think it was King Henry. I can't remember. At some point they just stopped. Every king they would change. They're like, screw it. Let's just stay with Henry. However long his foot was a foot. However big his thumb was an inch. Yay! That's crap. I don't know if you guys know that. So stay with me. Is that cool? 10 times 10 is 100. So this number would be 527. Right? Because I have 5 hundreds.
So 500.
2 tens, 20.
27.
717. I love it. So what's the next place? Add a 0.
10,000. 10.
You're ahead of me.
10,000.
1,000. 1,000. Because you add 1 0. You with me?
Yeah.
So if I put an 8 there, what number is that?
8,527.
I love it. So you got 8,000s, 500s. Yeah. So now if I do something freaky like this, what place is this? That's 1,000. So I take 1,000 and I add a 0. Now that's 10,000. So I have no 10,000s, right? See that? I have no 10,000s. But I do have 400,000s. So that would be 400,000. It's actually 408,000. You with me? But it'd be 400,000 from there, plus no 10,000s, 8,000s, plus 500s, plus 2 10s, plus 7 ones. So that'd be 408,527. That's how I'd say that word.
So 408,527.
Kick ass. right? All right, so you got a really, really good start. Yes? Yeah, sure. Okay. Really good start. And the minute you understand how that works, you can just keep going the same way we were going forever. Until you go crazy. But at some point, does that make sense? So now you think about the place that the number's in tells me what that number represents.
I know.
Okay. A lot better than you did a minute ago. Right? All right. So section 1.3. This is where we start to get into, let me see, I think 1.4 they break it out. Oh, good. Okay. Make sure they're doing that yet. No, okay, this is just the basics. Good. The only thing to be careful about here, this is not even doing something like 2 minus 7 yet. This is just making sure that we understand how to do something like this. And of course, what's the official way to do this? When do I start to get a problem? 4 minus 3 is good. I can't do 7 minus 9.
No, so you add.
Oh yeah, I'm with you. But I'm sorry, I was just saying that. I can't do 7 minus 9, but you're right. So that's why I got a problem there. So what do we got to do?
Bar.
Bar. I love it. So if we take this, good. Now realize what we just did. What does that 2 represent? Hundreds. So if I take 100 away from that, what does that 7 represent? 70. So if I take 100 from this dude and put it on him, he's now 170, isn't he? You guys kind of with me? That's exactly why borrowing works. So I know you all should be able to do that, but I don't know if anybody ever explained why it really works. So here I get 8, 1. So 181. I love it. So when I give you a quiz or a test and I give you a problem like that and you're not allowed to use your calculator, I have got to see this kind of work. If you are someone who can do math in your head, kick ass, it's an excellent way to be. I still need to see something. I don't live in your head. That would be weird. So I need to see how you're thinking about something. Don't just tell me, I don't know what you're doing back there. I don't know. You could be very good at hiding something. I don't know. So you have to show me how you're doing something. So that's the idea of borrowing. Now, of course, when you add, you kind of have the opposite thing. You have overflow, right? We have to give to the next guy something. So if I had that kind of thing. Oh yeah. What happens here?
16.
Yeah, so this is 16. Now, of course, I can't put 16 in one place. So the 1 with the 16 just kind of overflows to the next dude. So then I get 14, 11. So again, the 1 overflows. Good. So 446. We're good? Okay, so that should be basic stuff. And let me show you a really, really cool trick. Let me show you a cool trick. And I know I always get students that tell me, why should I know how to do this? Well, you should, but why should I know how to do this when I got a calculator that does it for me? I'm like, don't let technology be better than you. We're humans. We made the freaking calculator. If it knows more than us, we're on our way towards Terminators. Right? Human calculators will rise up. I don't want that. We should know how to do this basic stuff. So we can, if you rely on the calculator and you input crap, you're going to get crap out. It's very simple for us to hit the wrong button. Here's a really cool thing. One of the worst problems you could face would be something like, let's make it even worse. Right? Because you're like, okay, I don't have enough, I'm going to borrow. Oh, you got nothing, I got to borrow. Oh, you got nothing. Oh, shit, you got to go all the way over. And it just gets really gross. So now, stay with me. Throughout the semester, I'm going to show you what you would call a shortcut, but I don't like the word shortcut because that implies that you're skirting your way around something. This is just an easier way based on that we understand what's going on. What's 9 minus 5? 4. So if I do 9 minus 5, I get 4. So what's 8 minus 4? 4. So 9 and 5 are the same distance from each other as 8 and 4 are. Because we know that subtraction is math's way of finding how far apart things are. Right? You guys with me? I like that reaction. So what I can do with this, now watch this. 100,000 and 79,874 are the same distance from each other as 99,999 and 79,873. Same exact idea. If I make the bigger number 1 less and the smaller number 1 less, when I subtract, I'm going to get the same damn answer. You with me?
Yeah.
So it's not what I would call a shortcut. It's I understand what math is trying to do, so I make the problem easier to work. Right? Back to exacts. And it's going to help us when we do decimals the same way. So now this is so much easier because I don't have to borrow. Now I've got a bunch of big-ass numbers up here. I don't have to borrow anything. Right? So now I can start at the beginning. So you get 2, 0, 1, 2, 6. Yay! Whereas that, I don't even feel like doing that. Right? It's just oh, God, borrow them and put there. Okay. You guys kind of with me on that?
Do you just add the 2 that you took away?
No. All I did was take 1 away from the top one and take 1 away from the bottom.
Right.
Then they're guaranteed to be the same answer at the end. They're going to be the same distance apart. So, if I was standing at the 11-mile mark and you're standing at the 18-mile mark, how far ahead are you? 7 miles. Now, if later I'm at the 12-mile mark and you're at the 19-mile mark, how far ahead are you? 7. So if we both move by 1, the distance doesn't change.
Well, yeah, but when you're answering a question.
No. But the point is, if I move both of these numbers by 1, their subtraction will always be the same number as it would have been. They're always going to be. Subtraction, what does it really do? Show me how far apart two things are, right? When I subtract two numbers, I see how far apart they are. You guys with me? That's why we call another name for subtraction is difference.
Yeah, that's right. But at the same time, if that comes like one of the questions in the exam,
Yes.
so would the answer like 20,126 will be 26 will be all right?
Why
Because
not?
that's not the same number then.
That's what I'm
No. Okay, let's do this problem.
It's the same answer.
Let's do this problem. How do I do this problem officially? I actually got to start way over here, right? Because I got to borrow from him. Then I can borrow from him. Then I can borrow from him. Then I can borrow from him. And then I can borrow from him. Holy shit. All right.
I just got it.
And do you see, some of you guys might even see how the math there is exactly what I just did. It's just quicker. Right? So I desperately want you to understand. Math is more flexible than you realize. There is something that every math procedure is trying to accomplish. If you understand what it's trying to do, you can then come up with a better way to do it. You with me? You can do that in a lot of places. Now you got to be careful. You can't do that with every damn thing. You can't come up with some way to move things around to help you with multiplying large numbers or something. You just got to deal with it. But in this case, there's a really nice thing we can do. And this is even just for a very specific situation. Now watch. If I had this instead, could I still apply the same reasoning? Yes. I just won't go down by 1. I'll go down by 2. So I'll take him down to 99,999, and I'll take him down to 79,872. It's the same exact idea. There's nothing magic about the number 1. If I move him by 2, I move him down by 2. Easier problem, same answer. Right? So I don't have a damn problem with understanding math to the point where you can make the problem I give you easier to do. That's this. I cry. I'm like tears of joy. That's exactly what math is supposed to be about. It's what is it asking me to do? Is there a better way to do it than just the textbook way? Right? Has anybody ever seen that before?
No.
See, it sucks. Okay. It's real.
The reason you're moving it down by 2 on the lower one is because
If I
you
moved
don't
it
have to
down-
borrow in the ones column.
If I moved it down by 1, I'm like in this situation.
Right.
So move it down by 2, I'm there. So you can, and if I had a 7 there, you move it down by 8. You know, if you don't really understand that shortcut, you never have to do it. You can always do this. This still, of course, works. It's the textbook way. It'll work every damn time. I'm not saying that if you don't do this, I don't like you or something stupid, right? I'm just saying there's another option. If you like it, do it. If you don't like it, never do it. Yeah.
What's the situation where it might look like we can do that, but it wouldn't work?
People, obviously, if it's plus, you can't. What you could do with plus is you could, I don't want to get too deep into this, but with addition, if you make one go down, the other one's got to go up so that they still add to be the same number. What's 4 plus 6?
10.
If I make this become 5, this has got to become, to still be 10. So I made that one go up, I made that one go down. So for addition, you have to actually make them go in opposite directions for it to come up to be the same. Now that's getting way too deep into that idea. You can actually keep going with multiplication and do some weird shit with it there, but it definitely gets a lot harder there. Yeah.
So the same thing with rounding, right?
With rounding, it's not quite there yet. Rounding would be more like 4.9. You can round that to be 5. Because like you said, this number is
Yeah.
5 or up.
Then bigger than 5.
Kick-ass. So rounding's going to come into play, and it's going to actually be in a few different places in the book. But it's not here yet.
Darn it.
It's coming. All right. So I really want you to understand. I'm going to show you a lot of different ways to do things. I'm not saying you have to do them. I'm not saying if you do them, I like you better, or any of that kind of crap. It's just, does it make sense? If it does, do it. And what I really love, the reason I don't make you guys do like online homework, have you guys ever done online homework? In the classes I do it, I make it optional because I still get a lot of negative feedback from students. There's a lot of good stuff with it, but it's mostly bad. But another thing I don't like about it is I never see students work that way. And that's the way I can really get in your head and see what you're thinking. And a lot of times I steal, I'm like, that's a cool way to do that. I'm going to teach it like that now. So I steal stuff from students all the time because you get taught something in high school. I've never seen it that way. Right? There's a million different ways to do something, and if I like it, I'm going to steal it. So that's why I like to grade homework, is because I'm a thief, really. So what's, just to get a little ahead here, what's weird with the number 0? Can anybody tell me something weird about 0? Well, it's kind of like the opposite of infinite.
It's nothing.
Yeah, it's nothing. But what's weird mathematically with 0? When do you have weird things happen with 0? Yeah, well, multiplication, what happens when you multiply by 0? You always get 0. What happens when you add 0 to something? It stays the same. It's actually called the additive identity. 7 does not have its identity changed when you add 0 to it. So that's why it's called the additive identity. It doesn't change its identity when you add it. You kind of with me? So a lot of terminology sounds all hyper bloated. It's actually just saying something very simple. It doesn't change when you add it. What the hell happens here?
0.
Nope. What's the difference between that and this?
Oh, this one's 0.
Now, let me ask this. Let me start there. What's that?
3.
Good, because that's 6 divided by 2 is 3. Why is 6 divided by 2 3? I love it. Sweet. Very often I have to lead people. You're like, what do you want from me there, Jeff? But because 2 times 3 is 6. You with me? Now, I can do this one. Because what number has to go here? 7 times it must be 0. Well, 7 times what is 0? 0. So, of course, if I have nothing, and I have 7 people who want something from me, how much can I give each of them? Nothing. 7 people. Where's my money? Just beat me. I got nothing for you. This is freaky. The number that goes here has to be the number that when I multiply it by 0, I get 7. That's what that says. You with me? Why is this 3? Because 2 times 3 is 6. 7 times 0 is 0. 0 times something is 7? Can that be? No. Is there a number defined to do that? No. So that's why we call this undefined. Don't worry, I'll get to you. Somebody said infinity or infinite. That's sort of right in a way. Not quite. It's better just to say that damn thing is not defined. Has anybody ever heard the word undefined for that? That's why that word is there, because there's no number defined to do that. You guys got it with me?
Yeah.
Okay. So division by 0 cannot happen. Yes, sir.
So like 6 divided by 2 is 3?
Yes, definitely. Because division is sort of the opposite of multiplication. So when I say 6 divided by 2, I'm saying what's the number that if I multiply by 2, it would give me 6? It's thinking backwards. So what number would I multiply by 2 to give me 6? 3. Is that cool? So then, you know, like 10 divided by 2 would be, what number do I multiply 2 to get 10?
10.
5. Right? 2 times 5 is 10. So then 10 divided by 2 must be 5. So that's all division means is when I take a number and I divide something by it, you're thinking 6 times what equals 24? 4. So 24 divided by 6 must be 4 because 4 is what 6 is missing to multiply to make 24.
Okay.
So division is thinking backwards.
That's cool.
I like that. I don't hear that very often about division, but it is cool. So does that make sense too?
Yes.
Okay. In future classes, you might call it infinite, especially when you're talking about, and we will get into this in this class, when we talk about slope of a line. So eventually we'll get there. But for most of the time, it should just be called undefined. That's really the more direct way to refer to that. Okay. So that's 0. That's some things that 0 does freaky. It does other freaky things. We'll find out later.
So if we simply write undefined, that's the
It's beautiful. That's really the only thing I want to see. The biggest mistake I see is people tell me, like, this is 0. No good. Because then I'll say 0 times 0 is 6. You say, no, Jeff, I didn't say that. Well, yes, you did. If you write that, that's exactly what you said. Or, of course, I get 6 divided by 0 is 6. Same problem, right? That can't be true, because 0 times 6 is not 6. So there's no number I can put there to make it make sense.
But when you say it, like in a sentence, 6 divided by 0 will equal 6.
Not really.
Because 6 divided by nothing is not.
Now be careful. 6 divided by what is 6? 6 divided by 1. So it'd be weird if there's a whole other number that still comes out to be 6. It can't be. Anything I put, if I say 6 divided by something, and I'm using a variable a little bit early, but what the hell? If I say 6 divided by something is 6, that has got to be 1. There's no other answer for that. You with me? 6 divided by 0, you got to think, here's the weird situation. You with? If I have 12 things, and I got 6 people, everybody can get 2 of them. If I have nothing and I have 6 people, everybody can get 0. 1 second. If I have 6 things, and there's nobody around, not even me, right? If I'm around, if I have 6 things and there's only me, how much do I get? 6. But if I have 6 things, this is where I'm going to freak the hell out of you. This is why this is freaky. You can't even imagine the physical situation this describes. 6 divided by 1 is me with 6 stuff. It's all mine, right? 6 divided by 2 would be 2 people standing around. They each get 3. 6 divided by 0 is, I'm not even there. What? So this is undefined. I can't even come up with a visual to describe that because it's undefined. I can't even come up with it. Yes, sir.
Like 6, you put like a 6 and then put another 6 be 36 or what?
So if you do,
6.
well, 6 times 6 is 36.
Yeah, I know, but 6, if they put like 6 and put like a big line, you put like another 6 be 36.
No, be careful. 6 times 6 is 36. 6 divided by 6 is
It's 1.
1. Yeah.
So somebody told me it says 6 divided by, it's like this number 36. It's like,
Don't listen to them anymore. Don't listen, or make sure they were what they were saying. I think I've actually run out of time. It's crazy. We do run until 7:20, right? Yeah. That clock is right. 7. I think it's 7.